This is Algebra 1, Section 1.1, Variable and Expressions. Our learning goal for this section is to write mathematical expressions for verbal expressions and to also write verbal expressions for mathematical expressions. Please remember to fill out your learning goal on your math score sheet. So let us go through some vocabulary. First of all, in algebra, variables are symbols that are used to represent unspecified numbers or values. Any letter or symbol may be used. You want to be careful with some of the choices you make. For example, you want to make sure if you choose a T, it doesn't look like a plus sign. If you choose the letter O, it should not look like the number 0. Depending on how you write some of your letters, you will want to make good choices with that. Also keep in mind sometimes Greek symbols will also be used. Our next term is an algebraic expression. And those consist of one or more numbers and variables along with one or more arithmetic operations. Now, keep in mind about algebraic expressions, they cannot be solved, only simplified. You won't see equal signs in them, and you won't come up with answers that look like, x equals 2, because they are not equations. For these next examples here, you are asked to highlight the variable or variables in each algebraic expression. So if we look here at A, 5x, well, 5 is a number, and we'll learn the term for that later, but this x here is our variable. Our next example in B, we have 3 theta minus 7. So theta here, that's a Greek symbol. That is our variable in that example. For C, we have 4 plus the quotient of P and Q. We have P and Q as our variables in that one. And in example D, we have 3 times A times B divided by 5 times C times D. And our variables here are A and B and C and D. Then in number 4, we have M times 5N is the product of 5M and, the product of M and 5 times N. You'll notice that the multiplication symbol that you first learned of the little x and the letter x could easily be confused. And the variable x is used very often in algebra. So because of this, to avoid the confusion and to be able to communicate clearly, we are no longer going to use the x multiplication symbol. We will use x to mean a variable. So we need other ways to represent multiplication without using that symbol. So here are at least 5 different ways that you can do it. First of all, if we see something like xy here, you'll notice there is no symbol between them. That means that it's understood to be multiplication. Now, obviously, you couldn't do that with numbers. If I put a 5 next to a 3, that's represented as 53, not 5 times 3. So the lack of a symbol can only be used between variables, or a number and a variable, not two numbers. The other symbol we have here is the little dot, or we could put parentheses around the second term. We could put parentheses around just the first term, or we could put parentheses around both terms, and those all mean multiplication. Now, since in this section you're going to be translating from algebraic symbols to English and English to algebraic symbols, it's important to know what English words mean which operation. So here's a table to help you fill out these terms that will, hopefully you'll use on your assignment and you'll find helpful. So here is a list of terms below that I have found in your textbooks. Please forgive me if I forgot one or two. But let's go ahead and move these into the table, whether they mean addition, subtraction, multiplication, or division. Less or less than means to subtract. And we're going to point out later that it's important whether or not it's just the word less or if it is less than, because subtraction is not commutative. Order does matter. Then we have more or more than. That means to add. Now, if it's more or more than, that is not going to matter for the order because addition is commutative. Then next we have of. If we just see of all by itself, 99 times out of 100, it is going to mean that you multiply. Then we see minus. That goes under subtraction. Product, as we saw on the previous example, means to multiply. Times also means to multiply. Plus means to add. Sum also means add. Decreased by means to subtract. Divide means to divide. Yeah. Multiply means to multiply. Then we have give or take away. That would be subtract. Subtract, of course, means subtract. Then we have difference, means to subtract. Quotient means to divide. Increase by means to add. And, of course, add means to add. Next, we're going to talk about the parts of a power. What I have circled here in red, this whole entire thing is the power. Sometimes we mistakenly refer to them as exponents. Really, what part is the exponent in this case is the little n. The exponent is what tells us how many times to multiply the number. The number that's being multiplied, that number of times, is the base. But we would still read this as n to the nth power. There are, in the English language, a couple of exceptions to reading something to a numbered power, like the first power, second power, third power, and so on. And that would be such as a to the second power. We could also read that as a squared. The reason for that is if we have something that has two dimensions, such as a length and a width, it would make a square if those two dimensions were both the same length and width. Then if we had like b to the third power, we could read that as b cubed, because we would be talking about three dimensions, a length, width, and a height. And if they had the same length, width, and height, then they'd form a cube. Now, since we can only experience at one time three dimensions, we don't have names for anything beyond the third dimension. That's not to say that necessarily those dimensions don't exist. It's just the names that we give them in the English language. In mathematics, we do work with infinitely many dimensions in theory. And our last vocabulary term for this section, we need to know what it means to evaluate an expression, and that means you're going to actually find its value. They're probably going to give you a number to tell you to substitute in for a variable, and then you're going to come up with a number answer.